Hi guys! Today we have the Ecubmaker. It's a 4-in-1 machine capable of single or dual 3D printing, CNC engraving, and laser engraving. So let's start! As we mentioned before, today we have the Ecubmaker 4-in-1 to test. We will start with unboxing, then the machine setup, and finally some tests. But before we start, please don't forget to subscribe our channel and hit like. You can also visit us on Facebook, Instagram and Twitter, where you can find additional content. And if you want to support the channel, you can join our Patreon page.
Hey you guys! So, let's check what's inside the box. At the top, we have the user manual and an introduction card. Next, we have this big box containing lots of stuff, as we will see in a few seconds. And the machine itself. Everything is well packed, and inside the big box we can find another box that contains filament, the spool holder, one tool head, another tool head, and a third tool head. And finally, a box marked as tool kit. On every box is written what's inside, and this one is written dual FDM tool head. This is the tool head that will be used for single or dual color printing. The tool head is all made of plastic. At the side, we have the probe mechanism that will be used for leveling. At the back, we see the sliding system used to place the tool head on the carriage. At the front, we have a 40mm fan, and at the top, we have a 5x2 connector and a couple of fittings. This is a 2-in and 1-out type hot end. Removing the 2 screws at the back is all it takes to open the tool head. When this was launched, the manufacturer was sending one tool head for single printing and one for dual, but since the dual can also print with only one filament, they are now only sending this dual tool head. Behind the hot end, we can see a PCB with connectors and some additional components, which includes a couple of optic sensors for the probe sensor. The mechanism is simple. Pulling the top piece down will lock the probe out. There's a spring inside giving some tension to the probe, and pressing the probe in, we see the flag passing through the optical sensors. Pressing the side lever releases the lock and the probe goes in. Next, we have the laser tool head. The tool head looks exactly the same as the print tool head and also includes the same probe mechanism. The manufacturer states that the laser is 1.5 watts and 405 nanometer wavelength. There are no markings on the laser, so we have to trust the seller on this one. And this is the CNC tool head. The manufacturer states that it's equipped with a DC motor capable of operating at 10,000 RPMs. It's equipped with the same probe mechanism at the right side, but there are no sensors inside, so no auto level for the CNC engraver. Here we can see the DC motor with a small coupling and also a 40mm fan to cool it down. And now the spool holder. This is a very simple spool holder made from folded metal sheet, and there are no bearings for the rods on this one. The user manual is very detailed. It includes all the steps for installation and operation. It also includes instructions for the software. And at the cover, it's written the Z offset value for the printing tool head. Inside the toolkit box, we can find a cardboard with a laser demo, the USB cable, specific tools for the CNC engraver, glue stick and some other tools, the power cord, safety glasses for the laser, some acrylic boards for the CNC engraving and the memory card, a box with the power supply, cardboards, print surfaces and the CNC engraving surface. In this tool bag we have a glue stick, Allen keys and a Phillips screwdriver, a memory card reader, a couple of spare fittings, a spare PTFE internal tube for the hot end, thumb screws to secure the tool heads, and a spare end stop. This is an optic end stop and can be used for the X or the Y axis. Also inside the bag we found a small SMD capacitor. This component fell off from the end stop during shipping, so we will need to solder it before we can use it. Inside the CNC tool bag we have 4 metal pieces and 4 long screws that will be used to secure the boards to engrave, an Allen key to tighten the coupling set screws, 4 strong magnets, and an engraving bit. For the laser engraver, we have 3 cardboards and a couple of acrylic boards for the CNC engraver. For the printer, we have a magnetic print surface and also a spare surface. For the CNC works, we have this hard foam-like surface. This is the power brick. It's a 24 volt and 5 amp power supply. Also included are these safety goggles to use when working with the laser. There are no markings on the lenses stating what kind of laser these will filter, so we are not certain that these are okay to use. If you want to be truly safe, buy safety goggles from a certified seller and design for the laser you will be working with. Last but not least is the filament box. Inside, we have a spool with 300 grams of white PLA filament. And this is the machine. It comes fully assembled except for the tool head. The X carriage comes secured with a zip tie, so we need to cut it out. At the front, we have the on and off switch, and facing up is the control knob and the display. At the top, the machine is equipped with a light to illuminate the working area. Near the X-axis stepper motor, the machine has a tray and a couple of rubbers to clean the nozzle and keep the filament remains away from the printing area. All the axes move on linear guides, and all the end stops have optic sensors. At the right side, we have the memory card slot and the USB connector. At the back, we have both extruders and the input voltage connector. It's also equipped with a small cable track at the side. The print volume is 180 millimeters on all the axes, and the build plate is heated. As usual, let's check the electronics. To open the enclosure, we first need to take 7 screws from the bottom. Then we need to take the build plate out by removing the 3 screws in the middle of the bed. At the top, we have access to the lead screw. We can use a flat screwdriver to rotate the lead screw and raise the X gantry. And now we can take the cover out. Inside we have the board and a cooling fan. The board is a custom made and uses an 8-bit Atmega 2560 microcontroller. The drivers are Allegros 4982. The cooling fan is facing up and not to the board because they decided to use this big one and there is no room to have it standing up. To install the tool head is very fast and simple. We just need to slide it on the X carriage and then secure it with one of the thumb screws. Next, we insert the PTFE tubes, the one with the blue mark at the right and the one with the red mark at the left. Make sure the tubes go all the way in. And finally, the cable connection. Last but not least is the main power. And that's it. The firmware is also very simple to use. The first option is to select the file to print. In Filament, we have the Set Preheat Temp, where we can change the preheat temperatures for the nozzle and the heat bed, the preheat option, and the load and unload options. In Utility, we have the Auto Home, where it homes all the axes, the Move axis, where we can move each axis. In Z Offset, we set the probe offset value. In Change Tool Header, we select which tool head we want to use. In Restore Defaults, it restores the factory values. And in Printer Info, we can see some information like the firmware version and total printing time. For the first hardware check, we can run the home sequence. It starts by homing the X and the Y axis, and then starts to raise the X gantry. When reaching the top, it triggers and locks the leveling probe. Next, moves to the center of the print bed and probes the surface. To hide the probe back in, it moves all the way to the right and hits the X motor, releasing the lock. Inside the memory card, we can also find a couple of software programs. The first one is designed to work with every tool head. We have the printing option for single or dual filaments. We also have the laser option, and here we can find some presets. These will change the speed according to the material to engrave. And we also have the CNC option. And when we select the CNC, we can see the usable area reduced down to 112 millimeters. The second program is only for laser engraving. This one allows several image adjustments, so therefore provides better output results. Now we can insert the memory card and place the magnetic print surface. The spool holder is not the best one. The rods don't turn easily and the small spool does not fit properly. So for that reason, we decided to use our own spool holder instead. For single color printing, we need to use the extruder number 1, which is the top one. Inside the memory card, we have demo files for laser engraving, CNC engraver, single and dual printing, so we started with that. Since we have a leveling probe, we can use the G29 command after the home sequence to run the leveling. The printer probes the surface with a 3x3 matrix sequence. Even using the auto leveling feature, the first layer was not that good, but the other layers ran smooth. We also printed the traditional Benchy using our own slicer. One thing we need to add is that the cooling fan at the front will act as hot end cooling and layer cooling. This is not the issue. The issue is that this fan is not controlled by temperature. It's controlled by the M106 G-code command, which is the one used to turn on the layer cooling fan. If you don't add this command at the beginning of your start script in your slicer, the printer will keep the fan off the entire time or until it reaches the second or third layer depending on your layer cooling setup. Next, we tested the dual color printing. We loaded black PLA filament on extruder number 2 and orange PLA on extruder number 1. There are no labels on the extruders, and on the head we only have the red and blue marking, which makes it difficult to memorize which one is on the left or the right, or even which is the number 1 or the number 2. So for that reason, we made a couple of labels with the information that in our opinion should be there in the first place. With the dual printing, we had some initial issues. It started to print with the number 2 filament, and a few minutes later switched to filament number 1 without any issues. But when it switched back to filament number 2, nothing came out. We stopped and restarted a few times, and filament number 2 always jammed and didn't want to come out. So we took the hot end out and checked everything. The top section of the hot end has the PTFE tubes, then we have a small transition area, then we have a PTFE piece that will receive both filaments and lead each one at a time directly to the nozzle. We disassembled the hot end and removed the PTFE piece and found nothing that would explain the blockage for the second filament. The manual explains to feed both filaments only until the mark. We haven't before, so after doing that way, the filament switch worked and it finished the print. The only issue was that the filament switch and the purge position was on top of the second rubber blocking the nozzle. The manufacturer needs to fix this coordinate on future releases. And this is the finished 2-color print. The color transition was well made thanks to the purge tray and nozzle cleaning rubbers. The model that came in the memory card is this heart-shaped vase. It was not printed in vase mode, and it looks okay. Some minor horizontal lines, but nothing too serious. We slice the ripple cube, and with it, we can see some ghosting on the y-axis but less on the x-axis. The Benchy didn't turn out that bad at all. The layers are smooth, same with the details. It has issues on the corners and next to them, but it's all about retraction and its slicer settings from our profile. We do see some issues related with layer cooling, but again, nothing too serious. There is also a tiny bit of salmon skin on the cabin walls. One other issue we had was when removing the filament. The filament gets stuck in the fitting every time, and on both extruders. And the reason why is the blob that ends up on the filament tip. This can be easily fixed by drilling a bigger inner hole in the fitting. Next, we tested the laser engraving. The firmware cannot detect which tool head is installed, so we need to select the correct one. When selecting a different tool head, the firmware instructs to disconnect the machine and change the tool head. When the machine is powered back on, the firmware changes according to the tool head selected. For the laser, the firmware is even simpler. We have laser print guide, and in there we have several steps we need to go through until we can start engraving. First, we place the object we want to engrave. Then, the auto home center will home all the axes including the leveling sequence with the probe and positions the laser at the center of the build plate. Next, the laser pre-scan will turn on the laser with a lower power and move the X and Y to cover the limits. And then we have the set origin, where it will just set the position where it's at. And the last step is to choose the file to engrave, and it starts engraving. For the first laser test, we used the demo file, and this is the result. We tried using the main software for laser engraving, but that one is very limited with the image rework. Instead, use the one specific for laser because it gives you more options. Next is the CNC engraving. When using the laser toolhead or the CNC toolhead, we get the PTFE tubes hanging there. We use the recess at the back to stick one of the tubes and hold them in place, but there should be something to secure the tubes. For the CNC engraving, we need clamps, screws, magnets, the engraving bit, and the foam surface. Next, we place the magnets on the metal pieces, and then we use the screws to clamp these to the material we want to engrave. The screws are very long, so we can use materials up to 20 mm height and probably a little more. For our first test, we used the soft wood and the engraving bit that came with the machine. The coupling is too small, so the bit does not go much in, and there is some play in the system. Not perfectly solid as it should be. The foam surface has written the steps to start engraving, same as in the firmware. For the CNC engraving, we place the material on the bed, then we move the X and Y axis to the center of the bed and the Z down until the engraving bit barely touches the material. We set the origin and then select the file to use. The file was set to lower the Z just a little bit to engrave, so we noticed that it was engraving well on the right side and almost nothing on the left side. So we made a few measurements to check the x-axis, and we noticed more than 1 mm difference between the right side and the left side. The engraving depth is less than 1 mm, so this is an issue that we had to fix. At the back of the x-axis, we have 3 screws that we can loosen and adjust the leveling of the x-axis. The metal plate is not perfectly flat, so to be perfectly planarized, we need to use shims under the material. After the adjustment, we tried again, and this time the result was much better. The DC motor makes a lot of noise, and expect lots of debris from the engraving. The engraving area is smaller than the print area. The software limits the area down to 112 mm in X and 112 mm in Y. With the engravings, we confirm that a perfect leveling is a must. Even after adjusting the best we could, it is still noticeable one side less engraved than the other. And that's it, you guys. Hope you liked the video, and if you did, please give us a like. If you are not a subscriber yet, go ahead and subscribe and hit the little bell to be notified every time we publish a new video. Don't forget to check our Patreon page with exclusive content. You can also follow us on Instagram, Twitter, and Facebook. We will see you guys next time. Bye!